So this is just a continuation of more review of the factoring trinomials. Now, these are just nice and simple, just like before. All we're doing is looking for factors of 6, two numbers that multiply to give us positive 6, but who add to give me negative 5. So nothing unusual here. All you're going to do is list your factors as 6. Now notice this is a positive 6, but a negative 5. So both signs are going to be negative. So negative 1 times negative 6. But when I add those, I get negative 7. So that one doesn't work. But if I do negative 2 times negative 3, that gives me positive 6. And then when I add them, I get the negative 5. So x minus 2, x minus 3. Then for the next one, factors of negative 4, signs are going to be different because it's a negative, that when I add them give me positive 3. So the factors of 4 are just 1 and 4, 2 and 2, but I need one of them to be negative, and the one that'll be negative is the smaller number because the bigger number gets the sign of the middle. And then when I add these two, this is my combination. So it'll be x minus 1, x minus 4, or plus 4, sorry. So same stuff we did on these easy trinomials. On these easy trinomials, where the number in front of x squared is a 1, you could do the whole factor by grouping process if you want to stay consistent. However, as soon as I see it's an easy trinomial with just a 1 in front of x squared, I'm just going to go ahead and put it right into the two binomials. But again, if you like consistency and you want to do factor by grouping, you can. You could still multiply the first times the last, and it's just 1 times that last number.
So you can't do it this easy.
Now, let me just show you of what's coming tomorrow. So tomorrow, what we're going to do is actually factor, but then when the instructions say, they don't just say factor, they say solve, then all you're going to do is take these two factors you just found, and you set each one equal to 0. So x minus 1 equals 0, x plus 4 equals 0, and you solve them. So we would add 1, x equals 1, subtract 4, and x equals negative 4. So this is what we're going to add to the step, to the factoring process. Instead, it'll say solve, and this is what's going to be added in addition to the quiz. I'm also going to show you solving by square root tomorrow, but really we've already done that when we did Pythagorean theorem. So really it's not going to be that much of a difference or challenging moving forward for tomorrow. Yes. Just do a few more examples and then you can start your homework. So again, this one is actually a perfect square trinomial. So in the homework last night, you could have written your answer 2 ways on this one. But let me just show you. If you recognize that both of these are perfect squares, you could just square root the beginning and the end, put it into the binomial, but I highly recommend that you FOIL it to make sure you get the middle. Or do it the other way. Find two numbers that multiply to give you 9, but who add to give you the middle, and that's going to be 3 times 3 and 3 plus 3. On the big ideas homework last night, you could have also entered it as x plus 3 squared. So either one would be acceptable on the quiz on Friday as well as for big ideas. Now, this next one, here's where we're going to start with the factoring out the GCF. Everybody pay attention to this because in tonight's homework, you're going to have several questions where you must factor out a GCF first. Now this one, the GCF is just negative 1. Big ideas want you to keep your x squared term positive. So we're going to factor out a negative 1, which just essentially flips all the signs to opposite. Now, once you enter your answer in big ideas, you either need to enter this as a negative 1 in the front or just a negative sign. So we're going to multiply the beginning and the end. We're looking for factors of negative 30x squared. That will give me negative 1. Again, when this middle number is a 1 or a negative 1, that's a clue that the two numbers you're looking for are going to be side by side. And if you think about it, factors of 30 could be 5 and 6, but one's got to be negative, and the bigger number is the negative. It's the sign of the middle. Because when I multiply these two, I get the negative 30x squared, and when I add them, I get the negative 1x. So this is where we can't take the shortcut. We just need to factor by grouping here. 5x, let me put the 6 with the 3. It doesn't really matter. You're going to get the same answer either way, and then the negative 10. All right, so here I'm looking again. I've got my factors. I'm going to make my groups. So I'll make a blue group and a red group. My greatest common factor of blue is going to be 3x. And x minus 2 remains. Then my GCF of blue is going to be 5. And now I'm going to go ahead and put my two GCFs that I divided out together. 3x plus 5 goes together. And then just rewrite what was in common here, the x minus 2. And don't forget about your negative 1 that you factored out. So just know that this negative 1, if you'd rather do it like as a bracket, where you've factored out that original GCF, you could put it out there and then do the process of that trinomial. Now the next one is a binomial. Yes, and big ideas would let you enter it just as a subtraction sign as well. Okay. However, all we've seen so far are the difference of two squares. And if you take a look at this, you're going to be like, oh, these aren't perfect squares. However, these are both divisible by 3. My greatest common factor here is 3. So once we divide, you put the GCF on the outside. And now, after I've divided 48 by 3, I now have the difference of two squares. So now I need to factor this into x plus 4, x minus 4. And don't forget about your GCF. So all I did here was, once it was a perfect difference of two squares, all I did was square root. One gets a plus sign, one gets a minus sign. Because that's the GCF that I divided by at the beginning. We can't just forget about it. Yes? Perfect squares. If you try to just square root and square root, you're going to get 2x minus 12, 2x plus 12. Soon as you see something like this, where there's still a GCF hiding in here, you need to go back and start over again. Because I could still pull out a 2 here. So as soon as you see that, you need to go back and you need to say, wait a minute, I should have divided both of these by a GCF first. And my GCF here is going to be 4. I can divide them both by 4. And then I'm left with x squared minus 36. Now I still have the difference of two squares. And I'll square root it. And then this becomes x plus 6, x minus 6. It doesn't matter if you put the x minus 6 first and then the x plus 6. Either way. If you try to enter 2x plus 12 and 2x minus 12 in big ideas tonight, by not simplifying that, it marks it wrong. So you have to, mandatory, look for a greatest common factor first, then you apply all the rules for factoring that we've already covered. Let's try another one. This one will be a trinomial that also has a GCF. Next one. This time, always, before you start your factoring process, look to see, is there a number that will divide into all 3 evenly? And there is on this one. It's a 3. So I'm going to divide them all by 3 first. And then look how much easier it's going to be to factor. Factors of 6, that give me 7. and that's going to be 1 times 6, because 1 times 6 equals 6, and 1 plus 6 equals 7. So here, x plus 1, x plus 6. And there's your answer. Do not forget about the GCF. You need to make sure that you're putting it in front of your answer. Yes? So again, I'm going to multiply. This is one of the more challenging factoring problems. This one does not have a GCF. There isn't a number that I can divide 2, 5, -5, or 3 by to make it smaller. So I'm just going to go back to the factoring by grouping. I'm going to multiply 2x squared times 3, gives me 6x squared. So again, I'm looking for two numbers that'll multiply to give me that, but who will add to give me the -5x. So factors of positive 6, that'll give me a -5. That's going to be a -1 and a -6, or -2 and -3. But I need to add them. So the one that gives me the -5 is the 2 and the 3. So rewrite the problem. Rewrite the first term. Remember, all we're doing is replacing this middle with the two factors we just found. And again, the order that you replace them doesn't matter. I'll go ahead and just put the 2 first and then the 3. Now we make our groups. So I'll make a group here and then a group here. The greatest common factor of the first group is going to be 2x. Divide. GCF of the next group is going to be a -3, because if I pull out +3, my signs are going to be off. Yes.
How do we know when to do that, to pull out a -3 instead of
If you try positive and you notice that these two are not the same by pulling out a positive, then go back and change it to negative. Does that make sense? Yes.
Okay, I'm trying not to be disruptive here, but I'm trying.
So once I put this together, these two go together, and then the one that repeated, you just write it once. If you FOIL this, your goal when you're multiplying those first two is to get 2x squared, which was this first term. So you need a 2x there. Yes, so what I'm doing is I'm rewriting the trinomial. In the first term, the 2x squared gets rewritten. The last term gets rewritten. All I did was replace this middle with these two factors I just found. And then I make the groups. Okay, so then if you're going to FOIL this, which I highly recommend on these more challenging trinomials, that you FOIL it. So once I FOIL, first gave me 2x squared. Outside gives me -2x. Inside gives me -3x. And last +3. Once I combine those middle-like terms, it does go back to my original problem. So the answer I got here of 2x minus 3 and x minus 1 was correct. So again, the correct answer here is this. And then tomorrow, what we'll do is we take this one step further and we set each one of the binomials equal to 0 and we solve for x. And you can get fraction answers. It's okay. 2 more examples and I'm done. Yes.
Can I use the rest of your math sheet and put that?
Yes. Very good. All right, 2 more. All right, next one, same thing here. We're multiplying the beginning and the end because there is no GCF on this. So multiply 5 and -6, two numbers that multiply to give me -30x squared, but who will add to give me 13x. So 1 and 30, and the signs have to be different. The smaller number is negative, because remember, the bigger factor gets the sign in the middle. So once I add these, I get 29x. That one doesn't work. Try the next one. -2 x and positive 15x. That's going to be my combination. So again, I'm replacing the middle term, the 13x, with these two factors. Rewrite the 5x squared, replace the middle with the two factors you just found, and then rewrite the end. Factor by grouping. So make your two groups. GCF here is x. So 5x minus 2. GCF here is going to be 3. 5x minus 2. So again, these two look the same. So write it down once. And then take the two GCFs you divided by. And there's your answer. One last example. Multiply again. No GCF here. So 3 times 11 is 33. So two numbers that'll multiply to give me 33, but who add to give me 34. And that's going to be 1 times 33. Because when I add that, I get 34. So 1x plus 33x gives me 34x. So again, rewrite the 3x squared. Replace the middle with the two factors you just found. Doesn't matter the order you put them in. And then rewrite the 11. Make your groups. Look for a greatest common factor of the first group. It'll just be an x. Look for a GCF of 33 and 11. That'll be 11. And 3x plus 1. These now look the same. So write one of these. And then take the two GCFs. And they go together. And you're done. So again, just a little bit more practice. But what we added in today is that you always, no matter what, whenever the problem says to factor or to solve, you should always look for a greatest common factor first. Don't forget about the GCF. Make sure you bring it down throughout the problem.